Right, let's continue working on parser combinators. So we made a nice little library here with a bunch of parsers, and I thought this time we'd make an example, or like a more advanced example. And I think we can do like this. We can make examples. Folder, and in here we'll put a file called math, because what we are going to try is to parse some math expressions. And if I'm not completely wrong, you can do something like this. Sorry, example. And there we go. So this is a way we can run this example thing. But let me Google how to remove this annoying error message. All right, I think we are ready to go. So, what we are going to do is parse expressions like this. So, let's give it a try. We'll make a math parser here. Don't really know what it's going to have, but we do know it's going to implement the parser trait. So let's implement parser for math parser. And what kind of stuff we need here? We need parse. And how is it going to work? Well, first we'll need to pass a number. Well, first actually let's make a structure that we want to pass things into. And probably, do I need this? Okay, it cannot find pass result, which is weird because I thought I implemented everything. Maybe it's not public. Yes, that's the problem. All right. Anyway, so here we have a mathematical expression. Let's put it like that. And that can either be a number. For now, we just support signed integers, nothing else. Or it can be a binary operation. A binary operation is going to have an operator. And it's going to have the left-hand side, which is going to be another expression, the right-hand side, which is also going to be an expression. And this operator thing, what can that be? Let me get rid of this for now. This operator thing, what is that? For now, let's just say plus and multiply, like that. So for this example, we'd kind of like it to be, let's call it expression, we'd like it to be something like let's see. So we want a binary operation. This one has to be plus. The left-hand side actually has to be another expression, which is a number, and it's just 2. And the right-hand side, actually that is again a binary operation. So we get this kind of nested structure where the operator is multiplication. Left-hand side is a number which is equal to 3. Right-hand side is another number which is equal to 4. And let's see, that's the binary operation, that's the box, and there we go. So something like that. And course, I called it operator, so we need to just replace this guy with operator, like that. And maybe we can even derive debug these two. Then we can try to print it. So if we run that, we get some kind of things out. So at least it compiles. So we want to produce something like this from our math parser. How are we going to do that? Well, let's first make a parser for a number. So parse a number, and we need to, how is it? We need to take in the source, which has some lifetime. So I think we need lifetime here as well. And we're going to return a parse result, and the result is going to be an expression, I think. Right. So we already, from here, I think we have parse, or we just call the number here. Maybe, or we have this integer. That's what I'm looking for, and that produces an I64. So here, let's call it parse expression number. And the first thing we're gonna need is to get the actual number. So let's say we use the integer parser on the source. Or actually, this is going to be the rest and the number. And like this. Right, so now this should be the rest and this should be the number. And we can then return the rest, and then we create a number here with the number inside. And this should be all okay, like that. So doesn't says we don't need this lifetime, fair enough. Okay, so we can pass a number. Now let's try to pass an operator. Gonna be parse result expression, and here let's check what we have in our library again. We need some way to select between multiple options, which I'm pretty sure we have somewhere. We have the either, which is not going to be super nice when we have a bunch of things, but let's go ahead and use it. So it's either a literal that says plus like that, or it's this guy. So basically this, right, and pass in the source. That should be that. Okay, but actually not, because this is just a this is just going to be nothing basically. So what we need to do is we need to map this. Actually, we have to do it like this. We have to map, and we have to say, isn't that how? Let me just check. We get the map function. Yes. Okay, so let's call it result, and then we're gonna match the result, which is like a left or right. So we can say, okay, if it's a left, we knew it was plus, so we're just gonna return operator plus, and if it's right, we can return operator multiplication. And that's that, and then we actually run it in here. This should not be expression, of course, it should be operator. And there we go. Now we have an operator for that. We can actually do a similar kind of thing here. Let's take the integer, and let's say the value that we get out, put that into the number struct, and then just run that like that. It's a little bit more concise, and here we can even make it even more concise. We can do like this. All right, so now we have these parsers. Now let's try to make something that parses a full expression. So pass expression, we have the source, and it's again going to be an expression. So we can do something like this. First, we're going to need a number. So we run that. And here we can actually, let's just call it source. So we're kind of shadowing this and overwriting it all the time. What is the complaint here? Okay, whatever. So now we have the number. Now let's get some, like we can have a lot of white space. That's all right. So let's run that. And this returns a result, but we don't really care about that. Then we need the operator, but there might not be an operator. So we're gonna go ahead and say it's actually an optional operator that we pass on the source. And now this thing is, I should say source and operator. And if the operator is not there, we are actually happy to just return the number that we got there. Otherwise, if there is something, we're going to go ahead and say rest expression. We're going to call this function again on the source, and we're going to get the rest. Now the final expression is then going to be a binary operation where the operator is. So actually we can do something like this. So let some operator equals operator else. So we can use this let else thing. So it unwraps it if it's sum, otherwise it does the else clause. Anyway, now we can give the operator here, and we can say the left hand side, that was actually the number, and the right hand side, that was the rest. Finally, we can return the source and the expression. So now let's try to get this thing out. So let's go ahead and say source is actually 2 plus 3. Here we don't have any space, just for fun. And we're going to say rest, and expression is going to be pass expression on the source. And I'm just going to unwrap it for now. And we're going to print the rest and the expression. Okay, so it just hangs, which is probably because I'm not sure why it should do that. So it's just hanging. Actually, we should, we have to do this. So still not. Let's try something simpler. So that didn't work, because when we pass the number, is this one failing if we are empty? Or is this one failing? Yeah, I guess it's this one. So I guess let's say this is optional. We have to do that, I think, because I designed it so you have to explicitly say that it's okay if it's not there. Okay, so now it works. We got a number out. And if we turn this back on, it still hangs. So it must be because of this recursive call. And we can even, like, let's just debug the source here. It's not even that, which is the issue. So I guess it's these white space parsers. What if we get rid of them? Okay, so now we got something out. So it was the white space where evidently there's some problem with this many thing. So this one is also taking all of the white space. I didn't really think about that. So I guess we don't need, it's not a single white space, it's many. All right, so now I think we are cooking. Now we are cooking. Let's get rid of the source. Actually, let's just have it for fun. So you can see we get it 3 times actually, which is what you would expect. All right, now we get rid of it. And let's have our, let's call it the target. Because now we are going to see an issue that we have. Pretty sure. No, never mind. That was actually fine. But then if we do like this, I think we get the wrong thing. Now we get 2 multiplied by the result of the binary operation with plus. So that's not what we want. We want to do 2 times 3 and then plus. So the reason it doesn't work is we don't care anything about precedence in the parser here. So actually, to do this parsing, we should say also what is the precedence we want. That can be like a usize, and we'll only parse things with a higher precedence. So what we need to do is find the operator precedence. Let's say, let's not do that. Let's not do it like this. Let's just do it like this, inline. So we'll make a function called operator precedence that will work on an operator. Actually, let's make it a method. So it's like this. So we'll get the precedence, and we'll only pass things that are higher than that. All right. So what's going to happen is when we get in here, we will try to pass a number, some white space, and then the operator, and then some other white space. And now I think I want like originals. Let's keep that, because what we're going to do now is actually we do have an operator, but if the operator precedence is lower than the precedence I'm given, then we don't want to pass that. So we return the original source and what is the result? Of course, there's no result, so actually maybe we just return an error. And how is that supposed to look? It's with the source, and it's with, okay, so we need to return the original source, and it's kind of like awkward now because it's not really an error, but whatever. Let's do it like this for now. Return that, and then we have to implement is precedence. And we can just do operator plus. Okay, let's say it's 1, and operator multiplication, let's say it's 2. All right. And this has to be a string. So here we go. And when we start the parsing, we'll just like say, give us anything, and let's see what we get out of that. So it fails because we get an error out. That makes sense because we passed the multiplication. Actually, let's try to change it back to this one. I think that might work. So that actually does work. But in the case where we where this fails, we actually don't want to, because it can fail with the precedence thing. So we actually don't want that to cause the full parsing to crash. So let's match on it instead. And if it's okay, source and let's call it rest expr. Then we do something. If it's an error, don't really care about the message right now. What do we do then? So I think in this branch, we can probably put this stuff back in. Okay, but what do we do in this branch? So we're gonna return up to the caller. The caller is going to no, maybe then we just return. Okay, so here I think that this is how it's going to work. So if the precedence is too low for the operator, then we actually fine with that. We shouldn't. Let's call this one after number source. It's a little bit weird to do it like this, but maybe we can refactor it later. So we get the after number source, and then we simply return an expression which has the number. And then this was already a number. Then this is returned up, and how do we then deal with that? So that means basically this one is now fine. So let's say rest and rest expr. So this is all good still. And we have to make this thing. We make a binary operation, but now we don't return it because it could be that there is still more to pass. Right, but it means we have passed everything that we can now with our precedent. So I think we can do something like this. Rest again, and I don't know, let's call it rest again. So, but this time it's actually maybe there's something more. So we make it, you can't do that. Because, yeah, so it's not a good, it doesn't really work for parser combinators anymore because it doesn't have the right signature. So we cannot really use these combinators, which is of course not great. So we're gonna call it, we're gonna make it work. And the output is an expression. I think this is just how we do it. Right, let me see. It needs a lifetime. How did we write it? So we need a lifetime. Maybe, maybe not. But all right, so what this one is going to do is we'll make a REST parser. Like, actually we don't want this source here, we just want it like this. So I guess we have to say source. Hope it kind of makes sense. Okay, so anyway, this thing has to return now a function. So we create this function. And that function, when called, should return the parser result. This one, okay, it does need the lifetime, fair enough. So how are we gonna do that? Let's get the original source. Then we try to pass a number. Then we might have the early out, so we get that stuff. We pass the operator. We say, okay, actually, maybe there's no operator. Then we just return okay, it was just a number. Actually, the operator might be uninteresting for us, so we just do that. Otherwise, we are going to create a new parser that only takes things of higher precedence. Then we are going to run that parser. We are going to run that parser on the source. Okay. Then for some reason still has some issues. But anyway, now we have passed everything that should be bound into our right-hand side. So we create an expression with that. And then there might be another operator. So we can do like this. And this one I should call source, so there's no confusion there, I think. So there might be another operator. We check for that. I swear we're almost done. So if it's not there, we just return the expression we had before. But if it is there, then we need to say source remaining. Let's call it rest again. Why not? And then we need like need another rest parser, but this time it gets everything. So that's great. And then we run that guy, pass the source, and then that should be okay. Now we can finally final result. We can finally say expression. It's a binary operation. It's an operation where the operator is the operator. The left-hand side is this guy we made up here. which we just call the expression, but actually it has to be in a box. And the right hand side, also a box, but it's the rest expression. And we can say return OK, source, final result. I think that's correct, but let's see if we can't zoom out a bit and have like an overview. We don't really need this guy anymore. We don't really need this guy. We didn't need that guy, sorry. Okay, so that looks right. That looks right. And actually we can to make it even more clear, let's make a function that we call just pass expression, which is a pass result that returns an expression. And it's just going to construct this parser and then run it on the source. Right. And we can even use that here. Like we don't need that, so we just like pass expression like that. Because here it's anything. Here it is anything. I think. Let's see if it works. And I think it worked. So we have this expression 2 times 3 plus 4. And of course that should be turned into 2 times 3 first, and then plus 4. And we see here that we have the result of this whole expression is the result of plus, where the left hand side is the result of multiplying, and the right hand side is 4. So that is exactly this kind of thing. Left hand side is the result of multiplying, the right hand side is the result just number 4. So this little thing actually gave us a parser of mathematical expressions. This is very much inspired by Pratt parsers, which you might want to read up on. But yeah, I think that's it. Because what you can do now, we never needed this struct. That was not really necessary. What you can do now is just add more operators. So for example, a method call. That's kind of an operator, right? If you do like something dot whatever, then the dot is kind of an operator. And the way you would pass this is basically like you would like pass identifier. Okay. Then you know, you see that there's a method call. And then you pass an identifier, something like that. So that's one thing you could do. Another thing that is interesting, maybe we'll do it in another video, is to, let's add something else here. Let's add like a variable name. So it's probably has a string in there, whatever. And then we'd want to handle that. So we can say things like, what if we say a times 3 plus 4? And even this guy, we can make it just a string reference, because don't really want to copy data around. But we're not going to do that right now. We are going to stop the video here, and maybe in the next video we'll extend this parser. This is some of the nice. Is this nice? Is this nice? I don't know. Maybe it's a little bit confusing, but at least it's kind of fast to write. I mean, so this construct we have here, we can even reduce that. We can say, actually, we want we want like an enclosed thing, so it's optional white space. Okay, and then it's the parse operator, and then it's optional white space. So really it's this thing we want, and then we just pass the source, and then we can say, okay, the source and the operator is equal to that. And then I think, sorry, I made a bit of a mistake there. I think we can get rid of that. What did I say? I said it's an optional operator. Okay, so even this guy we have as optional, because the parser is not supposed to fail, I guess, if there's no. Does that make sense? Still parses the right thing. Just let's check also on this result. So now we have +2 and 3 times 4. So that's also correct. So it is actually doing precedence passing correctly. And even here we have the same thing. So maybe we get this thing and we call it our up parser. Is this, and we don't need to repeat that multiple times. Here we'll just say up parser pass source. Still works. But all right, that's gonna do it for this video. So I'll see you in the next one. Bye bye.